Hello and welcome to the AI Cloud Collision course. We'll be joined today by AI expert Daniel Hulme, who is going to discuss how AI is going to impact business and some of the things you need to consider as SAP customers. My name is Joe Campbell. I'm a sales director for EMEA for Lemongrass, and I've been in the SAP ecosystem for 30 years.
Thanks, Joe. I'm Daniel Hulme. I wear two hats for the past 25 years. I've been researching AI. My undergraduate PhD postdocs are all in AI. I'm currently entrepreneur in residence for UCL, so I help them spin out AI tech companies. I started a company 15 years ago that's been building AI solutions for some of the biggest companies in the world, and we were acquired by WPP 2 years ago, where I take on the Chief AI Officer role. I spend a huge amount of my time educating boards, organizations about how to embrace and utilize AI. So potentially I'll just jump straight into it. I've got a short presentation to share with everybody, and then I think Joe and I are going to have a conversation. So I'm just going to share my screen. So what I want to do is I want to give the audience potentially a different way of thinking about AI. So I'm going to talk a little bit about the history of AI, some definitions, and maybe a different framework to think about how we can bring these technologies into our organizations. So when building AI solutions, they typically have these three parts. Their organizations are going through their digital transformation. They're building their data lakes, and then they put some sort of analytics layer or analytics capability on top of those data lakes to enable them to ultimately make better decisions. Now, for some organizations, that's the right strategy. For other organizations, there are other strategies I think are more successful, which probably we'll talk about later on. But I just want to kind of demystify a myth about data. There is a myth that you need lots and lots of data to do anything interesting. I'm just going to give you two examples where that isn't quite true. So we were approached a few years ago by a low-cost airline, and this low-cost airline said, "Look, Daniel, we're collecting where people are clicking on our website. We collect where they look. We collect their purchase history. We know the name of their dog. We know what they're going to have for dinner. We want you to predict if they're going to churn, if they're going to go and buy from another low-cost airline." And I asked them, "Well, why do you churn? Why do you go and buy from another low-cost airline?" And they said, "Well, price. Well, if you don't give me the price of your competitors, then I'm not going to be able to predict churn." Usually, human beings know the data that contains a signal for prediction. A second example, not my example, somebody else's, but a short-term loan company wanted to predict if people are going to default on their loan. So this is where you borrow £1,000 and you have to pay it back at the end of the month. They were collecting all of their social data, their LinkedIn, their Twitter, their Facebook data. All of that data was actually useless at predicting loan default. There were two very good predictors of the default. The first predictor was a font, a typeface that was kept in their internet cache, and that font is often found on gambling websites. So if you're a gambler, you're likely not to pay back your loan. And the second indication was the number of mistakes they made when they were filling out the online application form, and that was an indication that people were intoxicated or high. So if you're drunk, you might want to borrow more money to get more drunk. So you don't have to have all of the data in the world. You have to have the right data that contains the signals to allow you to make better decisions. I guess also there's been an impulse for organizations over the past decade to hire data scientists, machine learning experts to extract insights from data with the expectation that by giving human beings better insights, that it leads to better decisions. And based on my experience, giving human beings better insights does not typically lead to better decisions. Humans are bounded by our ability to make decisions. I'm going to illustrate this in a moment. And I'm a big advocate of starting at the top. What's the problem that needs to get solved? It's probably a complex decision problem, which I'll talk about in a moment. What insights do you need to be able to then to make better decisions, and what data contains the insights? So let me just give you an example of why decision making is complex. So imagine these are 5 staff members. Ignore those rules on the right, they're not important. If I want to allocate 5 people to 5 jobs, there are 5 times 4 times 3 times 2 times 1 possible ways of allocating 5 people, 5 jobs. So there's 120 possible ways, 5 factorial, to allocate 5 people to 5 jobs. If I've got 15 people to allocate to 15 jobs, there are over 1 trillion possible ways, 15 times 14 times 13, to expect a human to solve this problem, to allocate these 15 people optimally, we're wasting our time. One rule I want people to take away today is anything more than 7, don't use a human for. And actually, industry don't have problems of this size, they've got problems of this size. So here are 500 staff members. How many ways can I allocate them? It's a big number. It's a number that's got over 1,000 digits. And just to put this number into context, this is how many atoms there are in the universe. Once you reach about 60 things that you have to consider, you've now got more possible combinations than you have atoms in the universe. Humans can solve problems up to 7. You can hire a good computer scientist that can solve problems up to 30, 40. Beyond that, you need to have deep specialized expertise in algorithms. And this is something that I want to really drum home. And maybe just to give you one more example, if I've got a delivery company that needs to deliver packages to these 24 points, after a few minutes, a human will draw a nice path around those 24 points. Now, how long will it take a computer to get the shortest path, the one that's going to save us the most amount of petrol and time? Maybe seconds or milliseconds, somewhere between that and 20 billion years. If you put 24 times 23 times 22 into your calculator, you get this number of routes at the bottom. And if you had a computer that could check 1 million routes a second, calculate 1 million routes a second, it would take 20 billion years to go through every single possible one of those routes and say, this one that I looked at 10 billion years ago, this one's the shortest one. If I had another point to the map, it's now 25 times 20 billion years, so 5,000 billion years. Another point to the map is 26 times 5,000 billion years. These are exponential problems. They get ugly very, very quickly. When building AI solutions, it's crucial that you use the right algorithms to be able to make the right decisions based on the right insights and that's got from the right data. But there are multiple definitions out there of AI. The most popular one, which I think is the weakest, is getting computers to do things that humans can do. Over the past decade, we've managed to get machines to do things that humans can do. Because humans are the most intelligent thing we know in the universe, we assume that when we get computers to behave like humans, that's intelligence. Now, there's actually a much better definition of AI that comes from the definition of intelligence. Instead of using human beings as the definition, there's this definition, which is goal-directed adaptive behavior. It's a beautiful definition. Goal-directed in the sense you're trying to route your vehicles to maximize deliveries or allocate your workforce to maximize utilization. Behavior is how quickly can I answer that question. We've just discovered if you choose the wrong algorithm, it will take longer than the age of the universe. If you choose the right algorithm, it can take milliseconds. But the key word in this definition for me is adaptive. What you want to do is build systems that make decisions, that learn about whether those decisions are good or bad, adapt themselves so that next time they make better decisions. The true paradigm of AI are systems that can safely adapt themselves in production. Adaptability is synonymous with intelligence. So a little bit of a history lesson before I give people a different way of thinking about AI, because if I held most of the things that we do in industry to this definition, almost nobody would be doing AI because most of our systems in production aren't adaptive. But I'll give you a different framework to think about AI just very shortly. So before I do, this is AI in the 60s and 70s. It was us writing down lots of rules and then trying to infer new knowledge from those rules. So this is Socrates. He inspired the Socratic method. So if Socrates is a man, all men are mortal, I can predict that Socrates is mortal. And it didn't really work. It didn't really scale. In the 80s and 90s, a new type of AI came along that's modeled on how brains work. This is the brain of a bumblebee. My PhD 20 years ago was trying to model the brain of a bumblebee in a machine. Bumblebees have 1 million brain cells. Their brains can their brains can fit on the end of a needle. Bumblebees navigate 3D worlds. They talk to each other. They solve problems. They don't handle windows very well, but ultimately they're very smart creatures. And the question was, can you model 1 billion neurons on a machine? 20 years ago, you couldn't. Now what we can do is we can build brains that have billions of neurons. These are what we call now large language models, and we can get these brains to do things that humans can do. These brains are really good at knowing things about the world. They're really good at telling you what they know about the world. They're not very good at reasoning, and they're definitely not very good at complex decision making. Use these brains to know things about the world, use these technologies to reason and make decisions, and then try to build systems that can adapt themselves in production. Now, again, most of the things that we do in industry don't really map to that definition. So more recently, I've been advocating looking at AI not through definitions, and not even through technologies, but through applications. And I believe there are 6 categories of applications of AI that organizations can think about how these technologies are applied to their business. So the first category is actually task automation. Task automation gets a bad reputation in the AI community. Essentially, it's using very simple algorithms, macros, if then else statements, robotic process automation to replace mundane, repetitive tasks that human beings are doing by things that are very simple. The fact is, if you deploy these technologies well, you can drive a huge amount of value in your business. The second category, of course, is content generation. So we've seen over the past year, we can get large language models to create imagery, sound, soon video, soon music, and everybody will have over the next few years the ability to generate any content they want, which is incredibly powerful. The third category is human representation. So this is where we take human beings that are an interface, whether it be call centers or salespeople, and replace it by AIs that look and behave exactly like a human being. And by the way, each one of these different categories raise different ethical and social questions. So if I replace a human being by something that looks and behaves like a human being, should I declare that it's not a human being? The fourth category is what people have been calling AI for the past decade, which is using machine learning, data science to extract insights from data, hoping that those insights lead to better decisions. But what's really powerful about these technologies is that it's not their ability to predict the world, but their ability to explain the world. They can actually tell you why correlations exist that help you understand the world more to be able to make better decisions. The fifth category that we've already talked about, which is complex decision making. Again, if you're old enough, this used to be called operations research, optimization, it's discrete mathematics. And again, I would argue if you deploy these types of technologies in the right way, you drive a lot of value in your business. And finally, the sixth category is human augmentation. So this is where we can take exoskeletons, cybernetics to augment and enhance your abilities in the physical world, but also we can create digital twins of people, of employees, of customers, to augment them in the digital world. So these are the six categories, and the reason why I love them is because it helps you actually navigate this complex world of AI safety and security and ethics and governance. The types of questions that you need to ask yourself when implementing task automation are very different when implementing digital twins of employees. The concept of a digital twin, I just want to close on, it's incredibly important. So right now, organizations are going through their digital transformation. They're creating a connected, open infrastructure to essentially enable them to create a digital twin of themselves. Right now, if you go to most organizations and you say, if I run a marketing campaign that increases demand by 10%, can I project across my supply chain? Will my suppliers default on their supply? Will I have enough space in my warehouses? Will I have enough delivery drivers to move the goods? Do I have enough people in my stores to sell the stuff to customers? And you can't really answer those questions right now. Most organizations' supply chains are disconnected, which is the impulse for trying to connect it all together by building digital twins, data lakes on the cloud. Now, I actually believe there are three types of digital twins that are going to converge over the next decade. The first digital twin is of your operating model, your business model, the flow of goods, products, and services across your supply chain. The second digital twin is of your workforce, that fluid, liquid set of skills, resources that you need to layer on top of that model. And then finally, processes like hiring and firing, these back-end processes, all of these processes are also amenable to disruption from AI. I think those organizations that are going to be successful over the next decade are the ones that move from digital transformation to digital twins and converge these three digital twins to enable them to be the most adaptive, most intelligent organization they can be. So on that note, I'm going to stop and hand back over to Joe.
Thanks, Daniel. Very, very interesting. So a couple of questions for us to have a discussion on. First one, so AI is being touted, rightly so, as the next industrial revolution. Do you see a clear roadmap for SAP-related AI?
It's really tricky. I mean, over the past year, generative AI has obviously transform the landscape. These technologies have been around for many years, and SAP and other type of ERPs have been embracing them over the past several decades to make better predictions, to be able to make better decisions. What generative AI allows you to do is essentially re-architect how data is stored and how knowledge is accessed. And I think that does potentially disrupt how ERPs like SAP will operate. I do think, though, over the next 5-10 years, not much will change. Business cycles, economic cycles, you know how it is, Joe, getting budget to actually implement this stuff, implementing it in production, it's hard and it takes time. So I think that these technologies do challenge the SAP type model, but I don't think we'll see it massively challenged for the next 3 or 4 years.
Okay, thank you. Okay, so given that we sensibly have no clear idea where AI will take us, do you think it's important for companies to create an infrastructure for SAP that is AI ready? Have you got any ideas on how they would prepare for this?
Well, I mean, this is your day job as well, Joe. But what I advocate is that there are several actually data layers that I think are really important to enable AI. There's the data layer that is your traditional kind of connected ERPs and your interfaces into them. The knowledge graphs are also an incredibly powerful way of representing data to allow you to make inferences, to allow you to find insights, and that is enabled by moving your data to a cloud and connecting it together. And then, as I said, there's this new type of kind of data store, these large language models that allow you to query your data in new and in interesting ways. And I think that that organizations need to now have a kind of a multi-layer strategy from a data perspective, and build the appropriate or engage with the appropriate AI technologies to solve the problems. I think we get excited about technology and we gravitate to new shiny things without thinking about what is the problem that needs to get solved and what's the right infrastructure to be able to then answer that problem. I mean, the fact though is that if organizations don't go on this journey, they don't enable themselves to become adaptable, then they're going to really struggle.
Okay, so bearing that in mind, and that it's all about technology-enabled transformation with business value, and that the IT teams that are currently involved in SAP and architecture have no idea where AI will take us, and your business owners and the budget owners here in the operations don't know where it's going. How do you think the company should structure themselves internally to get ready for this tsunami of change that's going to come in the next 3 to 5 years?
Well, as I said, I think this is your day job as well as mine. I'd love to hear your thoughts on this. I think there are multiple things that organizations should be doing. I'm a big advocate actually of agile type methodologies, so Scrum and whatnot, that they allow you to get an understanding of your resource, the skills, the hopes, dreams, desires of your employees. They also force you to be more rigorous about what work needs to get done, and then in theory you can use AI to much more effectively allocate that resource to that demand. So I think that's a really important journey that organizations need to go on. We also need to understand that the digital transformation is a process to get to a digital twin. And digital twins are a challenge because there's no one obvious owner of a digital twin. Is it the supply chain director? Is it the CMO? Is it the CEO? Somebody needs to be looking horizontally across the organization and thinking about the impact that these technologies have, not just on their business unit, but across the whole supply chain. And then from a very pragmatic approach, I think that you can create a collective backlog of frictions that exist across that supply chain and start to use the appropriate technologies to address those frictions, whether they be machine learning models or decision-making models, and then over time build your data architecture, build your data lake, and to build that digital twin over time. You don't have to build a digital twin to then get all the value from it. You can start to build your digital twin now and get value as you're building it out.
Okay, sounds very similar to what happened with ecom when it first came out, Daniel, when the ecom director, and then kind of disappeared. It became business as usual. But looking at that, like if you envisage a time when supply chain is being optimized with AI, customer interactions are optimized with AI, and all the market insight is optimized with AI. These are core areas for SAP. So would you see that it's going to come a time where where SAP will become the system of record and become transactional. A lot of these things will be done outside of SAP, like using data lake technology, or where would you predict that the impact's going to be on the SAP world and SAP itself?
It is difficult to predict. I think that the SAP type model is going to be challenged by the large language models, by these new paradigms, and it might be that, you know, SAP are a big smart organization, that they might also be embracing these technologies and augmenting their stack, allowing it to be an open architecture, interoperable, so you get the benefits of both types of systems. But ultimately, organizations are wanting to completely optimize themselves, and if SAP doesn't allow them to do that holistically, then organizations are going to look for alternative solutions. Yes, so that's where organizations are going. SAP can be part of that conversation. It might get elbowed out, or it can actually thrive and try to essentially grow its business into those new opportunities.
So it sounds like there could be opportunities of SAP having AI involved in everything it does, but a lot of the big heavy lifting might be done outside of SAP. But it remains to be seen whether they'll keep up with the level of innovation. So finally, will AI kill SAP, or should we not worry about the roadmap and let AI figure it out?
I think first of all, deferring to AI is a popular solution nowadays. I think that the next 10 years is going to be very interesting. I think organizations are going to realize that they need to embrace these technologies in one way or the other. They need to enable themselves on the cloud. They need to be able to get access to the insights, deploy those insights, make better decisions, so for them to thrive. So we're going to see that will happen over the next 10 years. Beyond that, it's very hard to predict. I think that these technologies are going to disrupt humanity, society in many ways. And so I tend not to predict the next 10 years. I think that SAP model will be challenged. I think where there's a challenge, there's an opportunity. But ultimately, if there isn't an alternative for organizations to become more efficient. They have to become more efficient. They have to become more effective. They have to unlock the creative capacity of their workforce to enable them to innovate. So having a platform and methodologies, organizational structures like Agile and Scrum coupled together to allow them to adapt more quickly to a changing world is where organizations are ultimately going to survive and thrive.
Okay, great. So thanks very much, Daniel, for today. That was really interesting. So I think in summary, we're saying you can't sit back and just wait for this to happen. Like, organizations need to be proactively looking at where you're summarizing, like where they've got friction, and start to look at, in an agile manner, how they can kind of build a backlog and look at which technologies, as they come into the market, can help them to take them forward. And that'll be used in a combination of SAP, cloud technologies have been on the cloud to give that agility, and also building up your data lake with structured data to enable you to be ready to adopt these things. Is that a fair summary? Or
you said it better than me, Joe. So
I don't think so. Okay. Well, look, thanks very much for everybody who's watching this, for coming along and seeing our little vlog today. And if you get any questions, feel free to reach out to us, and we're happy to engage you. So thanks a lot, and thanks again, Daniel. Okay.
Thanks,
Goodbye,
Joe.
everybody. Bye, Daniel.
Bye.